All right. Section 3, slope. Super important. Super important. Okay? Now, you guys are going to watch for a minute, and I want to define some things. I want to talk about some things. But this down here is an important equation that we're going to write later. Okay? And I'm going to write it separately so you'll know what to write. Let's just look at this together. All right? It says the slope m. When we're talking about linear equations, when you see the letter m, I don't know why they chose m. I think it's Latin for rise over, for incline or something. I don't know. But m means slope. M stands for slope. When you see m, and we're talking about linear equations, it is talking about the slope of the line. Okay. Now, the slope of a non-vertical line, one that's not like this, okay, is the number of units the line rises or falls for each unit of horizontal change from left to right. What does that mean? Okay, look. Here's a point, and here's a point. How do I get from this one to this one? Well, I need to rise 1, 2, 3. So my rise is 3 units. And then I need to run to the right 1, 2. I always do rise and then do run. Always rise first, then run. Okay? And I run 2 units, and then I'm back on the line. Okay? That's true for all of these. From here, 1, 2, 3, over 2. Okay? I don't have more of this graph, but you can see each point on the line, if I just go up 3 and over 2, I'm back on the line again. That's the slope of the line. How steep is it? How shallow is it? Okay? Now, the slanted line at the right, the one we're talking about, it rises 3 units, which we just showed, for each 2 units of horizontal. It goes up 3 units for every 2 units that it moves to the right. Okay? So the slope of the line, the slope, m, of the line is 3 over 2. Always right. It's always rise over run. The amount we rise goes on top. The amount we run goes on the bottom. So we went up 3. We went down. We went over 2. What if I'm going down? How would I represent that, Taylor? Instead of rising 3, what if I went down 3 and over 2? How would I represent that in the fraction? Negative 3 over 2. We always let the negative be on the top, because we always rise first. Either we go up or we go down, and then we run to the right. Hang on, Clay. Let me keep talking. I may answer it. Okay? Now, let's look at this next bit right here. All right? The slope of the non-vertical line passing through the points, blah, 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 is this. I'm going to write the formula over here for a second. M, because that stands for slope, is equal to x sub 2 minus x sub 1. I'm going to tell you what that sub means in a moment. There are 2 different x's, and we have to distinguish between them. So we give them little names. This is x from the first point. This is x from the second point. I'm sorry. Whoa. See, I'm already messing up. Y sub 2 minus y sub 1, because the rise goes on top. So we put the y's on top, and then over x sub 2 minus x sub 1. Write that down. You're going to use it all the time. Okay? That's how we find the slope. All we need to find slope are 2 points. We subtract the y's, we put it on top. We subtract the x's, put them on the bottom. Then that's our slope for the line. Okay? Now, let's look at this next bit down here. The last bit. Okay? And it says, when you use the formula for slope, the order of the subtraction is important. Given 2 points on a line, you can label either one of them as the first point or the second point, x1, y1, and the other point is x2, y2. It doesn't matter which one you pick as point 1 and point 2. But once you pick them, you've got to make sure that you subtract in the same way. y2 minus y1 is over x2 minus x1. That always works. But look at this one. This is incorrect. y2 minus y1 over x1 minus x2. Do you see we didn't subtract them in the same order? Right? We took x from the first point and subtracted the second. That's not right. We need to go in the same